Any resolution training for high-resolution image synthesis. Traditionally, for unconditional image synthesis, a dataset of in-the-wild images is first preprocessed by removing images smaller than a target size, cropping images, and resizing everything to a common size. These processed images are then used for downstream training. However, preprocessing results in many wasted pixels, particularly for large images. Instead of discarding pixels, we propose to use every pixel from these images, which we explore in our AnyResGAN framework. But this creates a challenge. How can we use large, differently sized images with traditional GAN training? Our solution is to use a generator conditioned on coordinates based on cell GAN3 to create our images. Then, adjusting the sampling rate of the coordinates changes the scale of the image. But how do we make this work in practice? We first define a fixed patch size. This sets a coordinate grid, which is controlled by a scale parameter and a location parameter. We randomly sample the location parameter during training, and also randomize the scale, which affects the global resolution of the generated output. We use a similar procedure on our AnyRes dataset. We sample patch parameters and extract real image patches. Next, we take a coordinate grid and transform it with patch parameters prior to the generator. The generator also takes in the scale and a latent variable to generate corresponding fake patches for the discriminator. For our training data, we start with standard GAN datasets, and we scrape additional higher resolution images from Flickr. The base resolution dataset helps learn structure, while the larger images help learn texture. We perform a similar collection procedure on different image domains, and in practice, we only need a few thousand of these high-resolution images. We use FFHQ as a testbed of high-resolution ground truth to conduct controlled experiments. Using our continuous image parameterization, we can perform image synthesis at any resolution. Our model tolerates some distortions between synthesized resolutions, which can be beneficial in removing artifacts. While the current largest GANs are limited to 1024 resolution, our patch training strategy enables us to go beyond that while preserving texture details and global consistency. Next, to evaluate synthesis quality, typically images are evaluated using FID, which resizes all images to a common size to capture global structure before computing inception features. But this resizing operation loses high-resolution details, and our input images are not all the same size. Instead, we propose to sample random crops from the input images, which we call patch FID to capture texture, prior to the standard inception pipeline. Patch FID is correlated with standard FID on our FFHQ benchmark dataset, but it focuses more on details, so when we compare to super-resolution networks, such as LIIF and real ESR GAN, our model is able to generate more realistic textures. For a qualitative comparison, we can upsample the low-resolution output, apply LIIF, or apply real ESR GAN. Our AnyRes model tolerates distortions but can mitigate low-resolution artifacts. As an extension, we can use similar patch training on cylindrical coordinates to generate infinite images. To summarize, we propose training on mixed-resolution datasets to avoid discarding high-resolution pixels. We modify the generator to synthesize patches conditioned on coordinate input. This enables unconditional synthesis at arbitrary resolutions beyond 1024. And we can also extend our approach to generate infinite images.